Out there, beyond the familiar twinkle of our night sky, the universe stretches in ways our minds can barely grasp, an infinite canvas dotted with worlds so strange they seem ripped straight from the pages of science fiction. Imagine planets where diamonds rain from the skies, where a single year lasts 1,000,000 of our days, or where the sun never sets because it's locked in an eternal dance with its host star. These aren't just fantasies, they're real places discovered by astronomers peering into the cosmic depths with tools more powerful than we ever dreamed possible. And today, we're taking you on a journey to 25 of the most bizarre, mind-bending worlds ever found, places that will make you question everything you thought you knew about the universe. Think about Earth for a moment, our cozy, blue-green haven with its predictable seasons and steady orbit. Now, throw all that out the window. Picture a planet so close to its star that its surface is a molten wasteland where temperatures soar high enough to vaporize metal. Or one so dense, a teaspoon of its material would weigh as much as an elephant. These aren't hypotheticals, they're real exoplanets, each one defying the laws of physics as we understand them. From the moment the first exoplanet was confirmed in the 1990s, astronomers have been uncovering a menagerie of worlds that challenge our very definition of what a planet can be. And trust us, the further we look, the weirder it gets. So buckle up for a cosmic joyride, because we're about to dive into a catalogue of celestial oddities that will leave you in awe. Some of these worlds glow like cosmic light bulbs, others wander alone through the void without a star to call home, and a few might even harbor conditions that could, just maybe, support life in forms we can't yet imagine. This isn't just a list, it's a front-row seat to the most extraordinary discoveries in modern astronomy. By the time we're done, you'll see the universe not as a static backdrop, but as a dynamic, ever-changing arena where the rules are rewritten every time we think we've figured it all out. Ready to have your mind blown? Let's begin. Imagine a world where the ground beneath your feet isn't rock or sand but glittering diamond. That's the reality on 55 Cancri E, a planet so rich in carbon that astronomers believe a third of its mass could be pure diamond. Orbiting its star in a blistering 18 hours, this exotic world is so close to its sun that surface temperatures reach a staggering 2,700 degrees Celsius, hot enough to melt steel and turn carbon into the ultimate cosmic bling. Under that crushing heat and pressure, carbon atoms arrange themselves into crystalline structures, creating a surface littered with diamonds the size of mountains. But the real spectacle happens in the skies. With temperatures high enough to vaporize carbon, the atmosphere is filled with carbon gas. When this gas cools slightly at higher altitudes, it condenses into graphite, and then, under the planet's intense gravity, that graphite gets crushed into diamond as it falls back to the surface. Picture it, a perpetual diamond rain, shimmering like cosmic confetti as it plunges through superheated winds. Scientists call it carbon precipitation, but let's be honest, it's the most extravagant weather system in the galaxy. Discovered in 2004, 55 Cancri E shattered expectations about what planets could be made of. Most rocky worlds, like Earth, are silicate-based with iron cores and thin crusts. But this planet's carbon-heavy composition suggests it formed from a protoplanetary disk unusually rich in carbon, perhaps around a star with a higher carbon-to-oxygen ratio than our Sun. That makes it a rare window into how extreme chemistry can shape entire worlds. And here's the wildest part: while we can't see its surface directly, models suggest its darker patches could be vast oceans of liquid graphite lapping against shores of solid diamond. What does this mean for our understanding of the universe? For starters, it proves planets can form in environments we once thought impossible. If diamonds can rain from the sky on 55 Cancri E, what other astonishing phenomena might exist out there? This planet doesn't just defy expectations, it rewrites the rulebook, showing us that the universe is far stranger and far more creative than we ever imagined. If 55 Cancri is the universe's jewelry box, then HD 189733b is its nightmare, a planet where the sky isn't just hostile but downright murderous. At first glance, this distant world appears deceptively serene, its atmosphere glowing a deep, tranquil cobalt blue, but don't let the color fool you. This isn't the gentle blue of Earth's oceans, it's the signature hue of a planet where winds scream across the surface at 5,400 miles per hour, hurling razor-sharp shards of molten glass sideways like cosmic bullets. How do we know what this hellscape looks like? Astronomers used a technique called transmission spectroscopy, analyzing how the planet's atmosphere filters the light of its parent star during transits. The blue tint comes from silicate particles in its upper layers, which scatter shorter wavelengths of light. The same way Earth's sky appears blue, but with a far deadlier twist. Those silicate particles aren't just floating. They're superheated into molten glass by daytime temperatures that exceed 900 degrees Celsius, then whipped into horizontal storms that would shred anything in their path. The planet's extreme conditions stem from its tight orbit, just 2.2 million miles from its star, completing a full revolution in just 2.2 Earth days. This proximity creates tidal locking, meaning one side perpetually faces the scorching star while the other languishes in eternal darkness. The temperature difference between these hemispheres fuels those supersonic winds, creating a global tempest where the very air is a weapon. For any hypothetical life form, survival here would be unthinkable. The glass rain isn't just abrasive, it's propelled with enough force to strip flesh from bone in seconds. Even if some ultra-resilient organism could withstand the heat, the atmosphere's methane and carbon monoxide would suffocate it long before the winds finished the job. Yet for scientists, HD 189733b is a treasure trove. It's one of the first exoplanets where we've mapped weather patterns in detail, proving that even the most violent alien climates obey physical laws we can decode from light years away. What's truly humbling is how this cobalt monster reshapes our understanding of planetary diversity. A world can be beautiful and deadly in the same breath, a reminder that the universe doesn't care about our definitions of habitability. Out there in the infinite black, nature's experiments run wild, and HD 189733b is one of its most ferocious masterpieces. Now let's shift from diamond storms and glass hurricanes to something that seems almost whimsical, a planet so lightweight it could float in your bathtub. Meet HAT P1b, a gas giant with a density lower than cork, defying everything we thought we knew about planetary formation. If you could somehow place this cosmic marshmallow in a vast ocean, it wouldn't sink, it would bob on the surface like a beach ball. At first glance, HDP-1b appears similar to Jupiter, with a diameter about 1.5 times larger. But here's the twist: despite its enormous size, it contains barely a quarter of Jupiter's mass. That means its atmosphere is stretched out in an impossibly bloated, diffuse layer, giving it a density roughly 1/4 that of water. Scientists aren't entirely sure what keeps this planet puffed up like a balloon. One leading theory suggests intense heat from its star, located just 3.6 million miles away, cooks the outer layers, causing them to expand far beyond what typical gas giant physics should allow. What's even more bizarre is its orbit. Most planets spin on their axis as they circle their stars, but HDP-1b is tidally locked, always presenting the same face to its sun. The day side roasts at 1,000 degrees Celsius, while the night side, though cooler, still simmers under the residual heat trapped in its superheated atmosphere. And here's the real kicker: it completes an entire orbit in just 4.5 Earth days, meaning a year here passes in less than a week. This planet forces astronomers to rethink how gas giants behave under extreme conditions. Traditional models can't fully explain why it hasn't collapsed under its own gravity or why its atmosphere remains so distended. Some speculate hidden energy sources like internal heat or magnetic forces might be propping it up. Others wonder if its composition lighter than expected, with more hydrogen and helium, plays a role. HTP-1b isn't just a cosmic oddity, it's a challenge to our textbooks. If a planet this bizarre can exist, what other rule-breaking worlds are waiting to be discovered? It's a reminder that the universe loves to surprise us, turning even the most basic assumptions about planets upside down, or in this case, keeping them afloat. Welcome to the darkest corner of the cosmos, TRES-2b, a planet so black it absorbs almost all light that touches it, reflecting less than 1% back into space. Imagine holding a piece of charcoal in your hand. Now picture something even darker, a world where the very concept of brightness seems alien. This exoplanet, orbiting its star 750 light-years away, is the blackest planet ever discovered, a shadowy enigma that defies explanation. At first glance, TRES-2b resembles Jupiter in size and composition, but that's where the similarities end. Unlike our solar system's gas giant, which reflects about a third of the sunlight it receives, this planet is a cosmic void, swallowing nearly every photon that reaches it. The secret lies in its atmosphere, a toxic brew of vaporized sodium, potassium, and titanium oxide compounds that absorb rather than scatter light. But even these ingredients can't fully account for its extreme darkness. Some scientists speculate the presence of unknown, light-devouring molecules or exotic cloud formations that trap photons like a celestial black hole. Detecting TRES-2b was a triumph of ingenuity. Astronomers spotted it not by its glow, but by the way it dimmed its star during transits. As it crossed in front of its sun, the planet's silhouette blocked starlight with eerie efficiency, leaving almost no reflected light to observe. Yet, in a twist as dramatic as the planet itself, closer examination revealed a faint, haunting red glow emanating from its superheated atmosphere. This eerie radiance, caused by temperatures soaring above 900 degrees Celsius, is the only hint that the planet exists at all, a smoldering ember in an otherwise lightless abyss. What makes this world even stranger is its orbit. TRES-2b hugs its star so closely that a full year lasts just 59 Earth hours, roasting its atmosphere into a perpetual, seething maelstrom. The proximity also locks one side in eternal daylight and the other in endless night, creating a temperature gradient that fuels violent winds. But here's the real mystery. Even the day side, bathed in relentless stellar radiation, remains impossibly dark. Theories abound, from the presence of light-absorbing organic compounds akin to those found in Earth's deepest oceans to the possibility of exotic matter rearranged by extreme pressures. Some even suggest it's a cosmic accident, a planet that formed under unique conditions, turning it into an astronomical anomaly. Whatever the cause, TRES-2b stands as a humbling reminder of how much we still don't understand about the universe. This isn't just a planet, it's a cosmic riddle wrapped in darkness. If light itself struggles to escape its grasp, what other secrets might it be hiding? TRES-2b doesn't just challenge our assumptions, it forces us to rethink the very nature of what a planet can be. Among all the bizarre worlds we've encountered, few spark the imagination like Gliese 581g, a planet so perfectly split between fire and ice that astronomers call it an eyeball world. Picture this, one hemisphere locked in perpetual daylight, scorched by the unrelenting gaze of its red dwarf star, while the other half languishes in an eternal, frozen night. But between these two extremes lies a narrow band of twilight, a ring of potential habitability where temperatures might just allow liquid water, and perhaps even life, to exist. Gliese 581g's unusual conditions come from tidal locking, a phenomenon where a planet's rotation syncs with its orbit, leaving one face forever turned toward its star. Earth's moon does this, always showing us the same side, but on a planetary scale, the effects are far more dramatic. The day side bakes under constant stellar radiation, with temperatures soaring high enough to melt lead, while the night side plunges to hundreds of degrees below zero, its atmosphere collapsing into a global ice sheet. Yet nestled between these two hellscapes, the Terminator line, the border between day and night, offers a tantalizing possibility. Here, the climate could be just right for water to pool on the surface, fed by melting glaciers creeping in from the dark side or vapor rising from the day-side scorched plains. What makes this planet even more intriguing is its location within the habitable zone of its star, the region where temperatures might support liquid water. While the day side is too hot and the night side too cold, models suggest the twilight band could maintain a stable, Earth-like climate. Rivers might flow from the icy wastes into sunlit valleys, creating oases where extremophile organisms similar to those in Earth's harshest environments could thrive. Imagine photosynthetic life clinging to the edges of perpetual dawn, or creatures adapted to migrate with a narrow band of survivable temperatures as the planet wobbles slightly on its axis. Of course, Gliese 581G isn't without its challenges. Red dwarf stars are notorious for violent flares, bombarding nearby planets with radiation that could strip away atmospheres or sterilize surfaces. The planet's gravity, about 1.5 times Earth's, would make movement difficult for any hypothetical life forms, and the lack of a day-night cycle could disrupt biological rhythms we take for granted. Yet extremophiles on Earth have proven life can adapt to the unlikeliest conditions, from boiling hydrothermal vents to Antarctic ice sheets. If life exists here, it would be unlike anything we've ever seen, shaped by a world where survival means forever balancing on the razor's edge between fire and ice. The discovery of Gliese 581G forces us to rethink what habitable really means. We're used to imagining Earth like worlds with familiar cycles, but this planet suggests life could flourish in the most unexpected niches. It's a reminder that the universe doesn't play by our rules, it invents its own, and as we keep searching, who knows what other strange sanctuaries we might find, hidden in the twilight between eternal day and endless night. While Gliese 581G presents a world torn between extremes, GJ1214b offers something even more surreal, a planet where water isn't just abundant but twisted into forms we can barely comprehend. Nicknamed the methane planet for its thick, hazy atmosphere, this distant world is a cosmic contradiction, a water-rich globe shrouded in a smog of hydrocarbons where familiar rules of chemistry break down under crushing pressures and bizarre temperatures. If you could stand on its surface, though you'd be instantly crushed and frozen, you might find yourself ankle deep in exotic ices hotter than boiling water, or gazing up at a sky tinged orange by perpetual methane fog. Discovered in 2009, GJ1214b orbits a dim red dwarf star just 40 light-years away, completing a full revolution in 38 hours. At first glance, it seemed like a typical mini-Neptune, a small gas giant with a thick atmosphere. But when astronomers peered closer using the Hubble Space Telescope, they uncovered something far stranger. Spectral analysis revealed an atmosphere drowning in methane and water vapor with no trace of hydrogen, a composition utterly unlike anything in our solar system. This wasn't just a gas world, it was something entirely new, a hybrid between a rocky planet and an ice giant, wrapped in a smothering blanket of organic haze. What really baffled scientists was the planet's density. Despite being nearly 3 times Earth's size, it weighed only 6 times more, suggesting an interior dominated not by rock but by water, and lots of it. But this isn't the water we know. Under pressures hundreds of times greater than Earth's deepest oceans, H2O molecules rearrange into exotic phases like Ice 7, a crystalline form that remains solid even at temperatures exceeding 300 degrees Celsius. Imagine glaciers hotter than a pizza oven or an ocean floor paved with superheated ice that never melts. Some models even suggest the planet's core might harbor ionic water, where extreme pressure rips apart water molecules, creating a soup of charged particles buzzing with electricity. The implications are staggering. If GJ1214b has a mantle of hot ice, it could generate internal heat through compression, potentially fueling hidden geological activity beneath its stagnant atmosphere. Some theorists speculate about a global ocean trapped between layers of high-pressure ice, a liquid realm cut off from the surface by miles of solid water. Others wonder if the methane in its skies could hint at even wilder chemistry, perhaps subsurface hydrocarbon lakes or reactions we've yet to imagine. This planet isn't just a curiosity, it's a paradigm shifter. Before GJ1214b, astronomers assumed water worlds would resemble scaled-up versions of Earth's oceans. Instead, we found a place where water defies every expectation, proving that even the most familiar substances can behave in alien ways under extreme conditions. If liquid water exists there, it wouldn't be a blue haven for life as we know it, but a pitch-black pressurized abyss, a reminder that the universe's creativity knows no bounds. Hold onto your seat because PSR J1719-1438b isn't just fast, it's a cosmic speed demon hurtling through space at mind-bending velocities. This planet completes an entire orbit around its pulsar in just 2 hours, making a year here shorter than a single Earth afternoon. To put that in perspective, if you were standing on its surface, though you'd be instantly vaporized, you'd witness a sunrise and sunset every 60 minutes with the sky whipping past at a blur. But the real shocker, this planet wasn't always a planet at all. It's the ghostly remains of a dead star, stripped down to its crystalline core by the vampiric pull of its pulsar host. Let's break down the horror show that is this system. PSR J1719-1438 isn't your average star. It's a pulsar, the spinning corpse of a supernova explosion, packing more mass than our Sun into a sphere no larger than a city. Rotating at over 10,000 times per minute, it blasts out beams of radiation like a cosmic lighthouse, shredding anything foolish enough to wander near. The planet orbits so close that its surface is bathed in lethal X-rays and gamma rays, while tidal forces from the pulsar's gravity, strong enough to warp space-time itself, keep it locked in a death spiral. So how did this planet even form? Astronomers believe it started life as a white dwarf, the dense remnant of a sun-like star. Over eons, the pulsar's gravity siphoned away its outer layers, leaving behind a planet-sized core of crystallized carbon, essentially a diamond the size of Jupiter. That's right, this apocalyptic speedster might literally be a giant gemstone forged in the heart of stellar annihilation. The pressures inside are so intense that carbon atoms are crushed into a lattice structure, creating a celestial diamond with a mass greater than our entire solar system's rocky planets combined. But survival here is impossible. The pulsar's radiation would fry any known material, while the gravitational tides stretch and compress the planet like putty, generating internal heat that glows white-hot. If that weren't enough, the planet's breakneck orbit subjects it to relativistic effects, where time itself slows down slightly from our perspective, a real-world twist straight out of Einstein's theories. What's truly humbling is how this system defies expectations. Planets shouldn't exist around pulsars. Their violent birth should obliterate any nearby objects. Yet here it is, a diamond-clad survivor of stellar Armageddon, dancing on the edge of oblivion. It's a testament to the universe's ability to transform destruction into something breathtaking, a jewel forged in fire, spinning eternally under the gaze of its undead star. Deep in the heart of the ancient globular cluster M4, drifting through a sea of stars older than our galaxy itself, orbits PSR B1620-26b, a planet that has witnessed nearly the entire history of the universe. At 12.7 billion years old, this world formed when the cosmos was a mere toddler, just 1 billion years after the Big Bang. To put that in perspective, Earth hadn't even been a twinkle in the Milky Way's eye yet. Our planet is a youthful 4.5 billion years old by comparison, meaning this ancient survivor predates us by more than 8 billion years, long enough to watch entire galaxies collide, stars ignite and fade, and the very building blocks of life assemble across the cosmos. This planet's existence defies the odds in ways that still leave astronomers awestruck. It orbits not one, but two dead stars, a pulsar and a white dwarf, locked in a gravitational waltz that should have torn any nearby planets apart. The system likely began as a normal binary pair, but when one star exploded as a supernova, the sheer force should have ejected any orbiting bodies into the void. Yet somehow, PSRB 1620-26b clung on, enduring the violent death of its parent star and the chaotic aftermath. Today, it's a relic of a time when the universe was still assembling its first generations of planets, a cosmic fossil preserved against all odds. What's even more remarkable is what its survival tells us about planetary formation in the early universe. Back then, heavy elements like carbon and oxygen, essential for building rocky worlds, were far scarcer, existing only in trace amounts forged by the first massive stars. Yet this planet's very existence proves that worlds could form even in those primordial conditions, perhaps around stars with compositions unlike anything we see today. Some theories suggest it might be a gas giant, its core enriched by the ashes of those early stellar explosions, while others speculate it could harbor exotic minerals unlike anything in our solar system. Imagine standing on its surface, if it even has one. The sky would be dominated by its two skeletal host stars, the pulsar, a spinning corpse flashing like a strobe light, and the white dwarf, a cooling ember fading into oblivion. There would be no day or night as we know it, just the eerie glow of stellar remnants and the cold light of ancient stars crowding the sky. Time here moves differently, not in years or centuries, but in epochs so vast they dwarf human history. The discovery of PSRB 1620-26b reshapes our understanding of planetary resilience. If a world can endure supernova, gravitational chaos, and 13 billion years of cosmic turbulence, what other ancient survivors might be lurking in the depths of space? It's a humbling thought, one that connects us to the universe's earliest chapters, long before our sun even flickered to life. Most planets are bound to stars, locked in eternal orbits, but not CFBD SIR 2149-0403. This cosmic nomad drifts alone through the void, untethered from any star, a rogue world with no sunrise or sunset to mark the passage of time. At just 400 light-years away, it's one of the closest free-floating planets ever discovered, yet its existence defies everything we thought we knew about how planetary systems form. How does a planet end up wandering the galaxy without a star? There are two leading theories. The first suggests it was violently ejected from its home system during the chaotic early days of planetary formation, flung into the abyss by gravitational slingshots from larger siblings. The second, even more intriguing, proposes it formed in isolation, condensing directly from a collapsing gas cloud too small to ignite into a star, left as a planetary mass castaway drifting through the cosmos. Without the light of a parent star to illuminate it, CFBD SIR 2149-0403 is nearly invisible, detectable only by the faint infrared glow of its own residual heat, a meager warmth slowly bleeding into the frigid vacuum of space. But here's the twist: this planet might not be as dead as it appears. Despite surface temperatures hovering around -400 degrees Fahrenheit, some scientists speculate it could harbor secrets beneath its frozen crust. Radioactive elements like uranium and thorium, remnants of the supernova that seeded its birth, might still decay in its core, generating enough heat to maintain vast subsurface oceans. If true, these hidden seas, shielded from the cold of space by miles of ice, could persist for billions of years, creating pockets of liquid water in an otherwise lifeless world. It's a tantalizing thought, a dark, wandering planet warmed from within, carrying the ingredients for life through the galaxy like a cosmic arc. Detecting rogue planets like this is a monumental challenge. Without starlight to reflect, they're effectively ghosts, only betraying their presence through subtle gravitational lensing or their dim thermal signatures. New telescopes, like the upcoming Nancy Grace Roman Space Telescope, aim to hunt these spectral worlds by spotting the telltale distortions they create in the light of background stars. Each discovery could rewrite the rules of planetary science, proving that planets aren't just accessories to stars, they can be solitary travelers, adrift in the infinite dark. What's most humbling about CFBD Sir 2149-0403 is how it redefines loneliness. This isn't just a planet without a star, it's a reminder of how unpredictable the universe can be, crafting worlds in ways we're only beginning to glimpse. And if liquid water can exist in the frozen heart of a rogue planet, how many other hidden oases might be drifting unseen among the stars? Step into a scene straight out of science fiction. Kepler-16b, a planet where two suns grace the sky, painting the horizon with double sunsets and casting tangled shadows across its surface. This isn't Star Wars Tatooine brought to life. It's the first confirmed exoplanet orbiting a binary star system, a cosmic ballet of gravity and light that defies our single-star perspective. Discovered in 2011 by NASA Kepler telescope, this gas giant revealed a truth astronomers long suspected. Planets could thrive in systems with two suns, dancing a precarious orbital waltz between their competing pulls. The mechanics of this celestial tango are breathtaking. Kepler-16b orbits both stars at once, tracing a wide, stable path around their shared center of mass. The stars themselves, a smaller, cooler orange dwarf and a tinier, dimmer red dwarf, circle each other every 41 days, creating a dynamic gravitational environment. From the planet's surface, their dance would dominate the sky. Some days, the stars would appear close together, bathing the landscape in overlapping golden and crimson light. Other times, they'd drift apart, creating staggered sunrises where one star crests the horizon hours before the other. Seasons here would be a spectacle of chaos and beauty. Unlike Earth's predictable cycles governed by our planet's tilt, Kepler-16b's climate would shift based on the star's ever-changing positions. When both suns align on the same side of the planet, their combined heat would scorch the atmosphere, potentially triggering violent storms. As they separate, temperatures might plummet, creating fleeting winters before the next stellar conjunction warms the world again. The skies would never be still, clouds swirling under the shifting light, shadows stretching and merging as the suns move independently. But the real magic happens at sunset. Picture standing on a rocky plain as the larger star dips below the horizon, its light fading to a deep amber. Just as darkness seems imminent, the second star lingers, casting a second, fainter glow that stretches shadows in new directions. The sky might blaze with dual twilight hues, fiery oranges from one star blending with the deeper reds of its companion. Moments later, as the second sun finally sets, the landscape would plunge into a darkness deeper than Earth's night, the stars' combined absence leaving an eerie stillness. Kepler-16b isn't just a scientific curiosity, it's a window into the diversity of planetary systems. Binary stars are common in the galaxy, more numerous than solo stars like our Sun, and this planet proves their potential to host worlds. While Kepler-16b itself, a Saturn-sized gas giant, is unlikely to harbor life, its discovery hints at the possibility of habitable worlds in similar systems. Imagine a rocky planet nestled in the habitable zone of two suns, where plants could photosynthesize under different wavelengths of light, or where creatures might have evolved to navigate the ever-changing cycles of light and shadow. This two-sun wonder reshapes our understanding of where, and how planets can exist. It's a reminder that the universe's imagination far outstrips our own, crafting worlds where the rules are rewritten under double sunrises and skies that never know a solitary shadow. If you think Earth's volcanoes are extreme, Corot 7b will make them look like campfires. This nightmare world, discovered in 2009, is a seething hellscape where the very ground is a global ocean of molten lava, stretching as far as the eye can see if any eyes could survive the 800-degree surface temperatures. But the real horror isn't just the heat. It's the planet's twisted fate, locked in a gravitational death grip with its star that stretches and squeezes its interior like cosmic taffy, keeping it perpetually molten. What makes this planet so unforgiving starts with its orbit, a blistering 1.7 million miles from its host star, 20 times closer than Mercury is to our Sun. At that distance, a year lasts just 20 Earth hours, and the gravitational tidal forces are so extreme they've likely ripped the planet's rotation to shreds. Scientists believe Corot 7b is tidally locked, with one side eternally scorched by its star while the other festers in darkness. But here's where things get surreal. That tidal heat doesn't just melt the surface, it churns the entire planet's interior, preventing it from ever cooling completely. The constant stretching and compressing generate internal friction, turning the mantle into a bubbling cauldron of liquid rock that erupts through cracks in the crust, flooding the surface with fresh lava in endless volcanic cycles. Now picture standing, or rather vaporizing, on this world. The heat is so intense that silicate minerals in the lava evaporate into the atmosphere, forming clouds of rock vapor. As these vaporized minerals rise, they cool and condense into tiny pebbles, which then rain back down into the lava oceans in a macabre cycle of geological cannibalism. Some models even suggest the night side, slightly cooler, could harbor rock snow, flakes of mineral condensate drifting onto lava fields that instantly devour them. But the most chilling possibility, Corot 7b might not have a solid crust at all. Some astronomers theorize the tidal forces have stripped away its outer layers entirely, exposing a naked iron core to the vacuum of space. Imagine a planetary skeleton, its metallic heart glowing white-hot, radiating heat into the void as it's slowly consumed by its own star. If true, this would make it one of the most metal-rich worlds ever found, literally. What does this mean for our understanding of planets? Corot 7b is a laboratory for extreme geology, proving that under the right conditions, even rock and metal can behave like fluids. It's a world where the line between surface and atmosphere blurs, where the very concept of solid ground is meaningless, and lurking in its depths might be clues to how planets form and die under the brutal embrace of their stars, less a planet perhaps than a dying ember in the cosmic forge. HD 209458b isn't just losing its atmosphere, it's being blasted into space at speeds that would make a hurricane feel like a gentle breeze. This scorching gas giant, located 150 light-years away, is so close to its star that its outer layers are being ripped away, creating a colossal, comet-like tail stretching over 200,000 miles. That's a river of gas escaping at 22,000 miles per hour, bleeding into the void in one of the most dramatic atmospheric disappearances ever witnessed. The discovery of this planetary exodus was a watershed moment in astronomy. When scientists first observed HD 209458b transiting its star in 2001, they noticed something bizarre. The planet's outline wasn't sharp. Instead, it was fuzzy, as if surrounded by a diffuse cloud. Further analysis revealed the truth. This wasn't just a hazy atmosphere. It was a vast plume of hydrogen gas being torn from the planet's grip by the sheer intensity of stellar radiation. The star's ultraviolet light bombards the upper atmosphere, heating it to tens of thousands of degrees and giving atoms enough energy to break free from gravity's hold. The result, a planetary hemorrhage so vast that it loses up to 10,000 tons of gas every second. To put that into perspective, Earth's atmosphere leaks, two hydrogen and helium atoms occasionally escape into space, but at a rate so slow it would take trillions of years to lose even a fraction of our air. HD 209458b, by contrast, could shed its entire atmosphere in less than a cosmic blink, geologically speaking. Some models suggest this relentless stripping might already have removed a quarter of the planet's original mass, leaving behind a scorched core shrouded in a thinning veil of gas. What makes this even more extraordinary is the tail itself. Unlike a comet's tail, which is pushed by the solar wind, HD 209458b's trailing gases are shaped by both radiation pressure and the planet's orbital motion. As it races around its star every 3.5 days, the tail twists like a cosmic banner, swirling with ions and leaving a detectable imprint on the star's light. Astronomers can actually track the composition of this lost atmosphere through spectroscopy, studying the chemical fingerprints of carbon, oxygen, and even water vapor as they're carried away into the void. But here's the twist. While this planetary bleed out seems catastrophic, it's also a gift to science. Watching HD 209458b's atmosphere evaporate gives us a front-row seat to processes that might shape the fate of many exoplanets, especially those orbiting too close to their stars. It's a preview of what could happen to gas giants in other systems as they age, or even to Earth-like worlds if they wander into the wrong orbit. And hidden in that escaping gas might be clues to how planets form, evolve, and sometimes quite literally fade away. The lesson of HD 209458b is as humbling as it is thrilling. Planets aren't immutable, they're dynamic, evolving worlds that can be reshaped or even destroyed by their environments. In the grand cosmic dance, some partners hold on tight while others are worlds apart, their essence scattered across the stars. Most planets follow the rules, orbiting their stars in neat, orderly paths that match the star's own spin, but not WASP-17b. This cosmic rebel defies the laws of planetary formation by moving in the exact opposite direction of its star's rotation, a phenomenon so bizarre astronomers call it a retrograde orbit. Imagine a solar system where the planets whirl like frenzied dancers spinning backward while their partner turns the other way. This isn't just unusual, it's a full-blown celestial mutiny. How does a planet end up with such backward motion? The leading theory involves a violent past, a gravitational brawl of cosmic proportions. Early in its life, WASP-17b may have been yanked off course by a close encounter with another massive planet, sending it careening into a tilted or even reversed orbit. Some simulations suggest it could have been a near collision, a gravitational slingshot so extreme it flipped the planet's trajectory like a skipped stone changing direction on water. Another possibility, the star's own chaotic movements might have warped the protoplanetary disk from which WASP-17b formed, leaving the planet to coalesce already spinning the wrong way. But the planet's defiance doesn't stop there. WASP-17b is also one of the puffiest planets ever discovered, a gas giant with the density of styrofoam, bloated to nearly twice Jupiter's size but barely half its mass. This super low density suggests an atmosphere stretched to its limits, possibly inflated by scorching temperatures from its star or internal heat left over from its turbulent formation. Some scientists speculate its gases might be so distended that they're actively leaking into space, creating a hazy, extended envelope that gives the planet an almost ghostly appearance. The combination of retrograde motion and extreme puffiness makes WASP-17b a double mystery. Normally, planets form from spinning disks of gas and dust that move in sync with their stars, like a potter's wheel shaping clay. For one to end up backward and swollen challenges not just one but multiple assumptions about how planetary systems evolve. It's a reminder that the universe loves chaos, that even the most fundamental rules can be bent, broken, or flipped entirely when gravity takes the wheel. What's next for this backward world? Over millions of years, its orbit may gradually decay, pulling it closer to its star until it's torn apart by tidal forces, a fittingly dramatic end for a planet that never played by the rules. Until then, WASP-17b spins defiantly against the current, a cosmic maverick rewriting what we thought we knew about how planets live and die. WASP-12b isn't just orbiting its star, it's being consumed by it, stretched into a cosmic teardrop as its host star drains its life away. Scientists call it the vampire planet, and for good reason. Every second, 6 billion metric tons of its atmosphere are siphoned off by gravitational forces, funneled into the star in a relentless flow of stolen matter. If Earth's atmosphere vanished at this rate, it would disappear entirely in just a few days. But WASP-12b has been enduring this stellar feast for millions of years, its gases torn away so violently they form a swirling bridge of superheated plasma between planet and star, a celestial umbilical cord feeding a monstrous parent. The planet's doom is written in its orbit, circling just 2 million miles from its sun, closer than any planet in our solar system. It completes a full revolution in just 26 hours. At this distance, the star's gravitational tides have warped WASP-12b into an oblong shape, stretching its near side into a bulging, molten nose while the far side tapers into a fading tail. The temperature difference between these hemispheres is staggering. The day side roasts at over 2,500 degrees Celsius, hot enough to vaporize titanium, while the night side, though cooler, still simmers at 1,000 degrees under the trapped heat of its own tortured atmosphere. What makes this planetary horror show even more macabre is the star's dining habits. As WASP-12b's gases spiral into the star, they don't just vanish, they ignite. The stolen material forms an accretion disk, a glowing ring of superheated plasma that radiates ultraviolet light as it's digested. From a distance, the system might resemble a demonic mouth, the star's gravity gnawing at the planet's flesh while the disk glows like embers in a cosmic throat. Even the planet's composition plays into this nightmare. WASP-12b is unusually rich in carbon, meaning its devoured gases might be seeding the star with the building blocks of exotic chemistry, turning the vampire into an alchemist. Astronomers predict a grim finale. Based on current mass loss rates, WASP-12b has less than 10 million years left, a blink of an eye in cosmic terms. Eventually, the star will strip the planet down to its core, leaving behind a naked, super-dense remnant that might continue orbiting like a ghost of its former self. Alternatively, tidal forces could rip the planet apart entirely, scattering its remains into a short-lived ring before they too are consumed. WASP-12b's fate offers a chilling preview of what might await other close-orbiting planets, including, one day, Mercury in our own solar system. It's a visceral reminder that gravity doesn't just guide worlds, it can devour them, a cosmic dance where partners sometimes don't survive the embrace. Gliese 436b is the universe's ultimate contradiction, a planet where ice refuses to melt, even when temperatures soar to 800 degrees Fahrenheit. This world defies all common sense, wrapping its surface in a layer of solid water while glowing like a cosmic oven. The secret, crushing atmospheric pressure, so immense it forces water molecules into an exotic state called hot ice, where the rules of chemistry bend to physics' will. Picture an ocean that defies all logic. On Earth, ice forms when water cools below freezing, its molecules locking into delicate hexagonal patterns. But on Gliese 436b, the opposite happens. The planet's gravity, 22 times stronger than Earth's, presses down on its atmosphere with such force that water molecules can't escape into vapor, no matter how fiercely the nearby star heats them. Instead, they're squeezed into dense, cubic crystal structures known as Ice 7, a form of solid water that remains stable even under hellish temperatures. It's as if the entire planet is wrapped in a pressure cooker where heat and gravity wage an eternal tug of war, trapping water in a state that shouldn't exist. The physics behind this phenomenon is as fascinating as the planet itself. Normally, increasing temperature breaks molecular bonds, turning solids to liquids and liquids to gas. But under extreme pressure, the rules flip. The weight of Gliese 436b's atmosphere, mostly hydrogen and helium, compresses water so tightly that molecules can't move freely enough to melt, even when soaked in blistering radiation from its red dwarf star. This creates a surface where ice doesn't just survive the heat. It thrives, its crystalline structure growing denser and more stable as temperatures rise. What would it be like to stand on this world? Forget the crunch of snow underfoot. This ice would behave more like hot, glass-like rock, its surface shimmering under the star's glare without ever turning to liquid. Below, the pressure might forge even stranger phases of ice, like Ice 10, a hyper-compressed form where water molecules align in ways never seen on Earth. Some models suggest the planet's core could harbor metallic ice, a conductive form where electrons flow freely, turning water into an electrical conductor. The discovery of Gliese 436b rewrote the playbook for planetary science. Before this, no one imagined ice could exist at such temperatures, proving that matter behaves in alien ways under extreme conditions. It's a humbling reminder that the universe's creativity knows no bounds, a place where fire and ice don't just coexist, but depend on each other to create something utterly new. Among the cosmic wonders we've encountered, none dazzles quite like J1407b, a world so crowned by rings it makes Saturn look like an amateur. This gas giant, orbiting a young star 430 light-years away, boasts a ring system 200 times wider than Saturn's, stretching over 75 million miles from edge to edge. To put that in perspective, if you swapped Saturn's rings for J1407b's, they'd dominate Earth's night sky, appearing larger than a full moon and casting eerie shadows across entire continents. The discovery of this Super Saturn was as dramatic as the planet itself. Astronomers first noticed something bizarre in 2012, when the star's light periodically dimmed in ways no ordinary planet could explain. Instead of the brief, symmetrical dips caused by a spherical world transiting its star, the star's brightness plunged erratically, sometimes for weeks, as if something vast and jagged were passing by. After ruling out starspots and cometary swarms, researchers realized the culprit, a gargantuan ring system tilted at an angle, eclipsing the star in a celestial light show unlike anything seen before. Imagine standing on a moon within those rings. The sky wouldn't just be adorned with thin, delicate hoops, it would be a labyrinth of bands, gaps, and spirals, some as dark as charcoal, others gleaming like fresh snow. Sunlight filtering through the rings would paint the clouds below in shifting stripes of gold and shadow, while moonlets embedded in the disk cast their own miniature eclipses overhead. The rings themselves aren't uniform, they're segmented into distinct zones separated by gaps likely carved by unseen shepherd moons whose gravity sculpts the debris into precise edges. One gap in particular, spanning nearly 25 million miles, hints at the possible birth of an exomoon, a baby world coalescing from the dust, destined one day to break free from its ringed cradle. What's truly staggering is the scale of this system. Saturn's rings, though majestic, are fleeting by cosmic standards, likely just 100 million years old and destined to fade. J1407b's rings, by contrast, are a youthful marvel, possibly as young as 16 million years, offering a snapshot of how moon-forming disks behave around giant planets in their infancy. The planet's gravity can't hold onto this splendor forever. Models suggest the rings are evaporating, their icy particles spiraling inward or drifting away into space. In a few million years, this spectacle could vanish, leaving behind only moons, or perhaps nothing at all. For astronomers, J1407b is more than a curiosity, it's a time machine. By studying its rings, we're witnessing processes that might have shaped our own solar system's moons billions of years ago. The gaps and waves in the disk reveal hidden gravitational dances, while the sheer breadth of the system challenges assumptions about how much material a planet can host in its orbit. It's a reminder that even familiar phenomena like rings can explode into unimaginable grandeur when the universe decides to show off. Yet the most haunting question remains: what would a solar eclipse look like from this world's surface? As the rings slide between the planet and its star, they wouldn't just block the light, they'd fracture it, bending sunlight through countless ice crystals to create a halo of prismatic shards. The star's glow might dim to a twilight shimmer for months, the sky streaked with luminous arcs as the rings filter its rays. It's a spectacle no human eye will ever witness firsthand, but one that ignites the imagination, proof that somewhere out there, a planet wears its jewelry on a scale we're only beginning to comprehend. Glimmering in the void like a cosmic jewel, JJ504b defies expectations with its surreal pink hue, a Jupiter-sized world bathed in the blush of its own fading youth. This isn't the ruddy tint of Mars or the deep crimson of a distant red dwarf. It's a delicate, almost ethereal magenta, the signature glow of a planet still radiating heat from its violent birth. At just 160 million years old, a toddler by planetary standards, JJ504b offers a rare snapshot of a gas giant's fiery infancy, its atmosphere pulsing with warmth that hasn't yet surrendered to the chill of space. Capturing this world's light directly was a triumph of modern astronomy. Most exoplanets are detected through indirect methods, shadowy dips in starlight or telltale stellar wobbles. But JJ504b, orbiting 59 light-years away, is one of the few photographed outright, its pinkish silhouette standing out against the black. Using the Subaru telescope in Hawaii, astronomers peeled back the glare of its parent star to reveal this planetary ember, a feat akin to spotting a firefly next to a spotlight from miles away. The result, a hauntingly beautiful image, a lone, rosy disk adrift in the darkness, its color so unexpected it sent researchers scrambling to revise atmospheric models. That mesmerizing pink isn't just for show. It's a cosmic clue etched in light. Young gas giants like this one still simmer from the energy of their formation, when collapsing gas and dust heated their cores to tens of thousands of degrees. As JJ504b cools, its heat escapes through layers of hydrogen-rich atmosphere, where methane molecules absorb red light while scattering shorter blue wavelengths. The mix creates a unique magenta glow, a fleeting phase in a planet's life that most worlds outgrow as they age. But here's the puzzle: current models struggle to explain just how pink it is. The color suggests atmospheric properties like cloud composition or heat distribution that don't align neatly with existing theories. Some scientists speculate the presence of exotic aerosols or uneven cooling patterns, while others wonder if its formation process left behind unusual chemical fingerprints. What's even more intriguing is the planet's orbit, a dizzying 44 times farther from its star than Earth is from the Sun. At this distance, traditional planet-forming disks shouldn't have enough material to birth a gas giant, yet JJ504b exists, challenging assumptions about how planetary systems assemble. One theory suggests it might have formed closer in before being flung outward by gravitational chaos, while another proposes it coalesced directly from a collapsing gas pocket like a failed star. Either way, its very existence forces us to reconsider the diversity of planetary origins. For now, JJ504b remains an enigma wrapped in a pink haze, a world that refuses to fit neatly into textbooks. As it continues to cool over billions of years, its vibrant blush will fade, leaving behind a colder, more conventional gas giant. But for this fleeting cosmic moment, we're granted a glimpse of planetary adolescence, a reminder that even in the depths of space, beauty and mystery often wear the same rosy glow. Kepler 453b isn't just another planet orbiting twin suns. It's a celestial tightrope walker, balancing in the narrowest sliver of orbital stability where most worlds would be flung into chaos. Nestled in the habitable zone of its binary stars, this rare circumbinary planet proves that life-friendly conditions can emerge even in the gravitational whirlwind of a two-star system. But calling it a Tatooine twin hardly does it justice. This world's dance with its dual suns creates seasons and daylight patterns so bizarre, they make Earth cycles look like child's play. The first jaw-dropping fact about Kepler 453b is its precarious perch. Unlike planets that orbit just one star in a binary pair, this world loops around both stars in a wide, circular path, a feat once thought impossible. The stars themselves, a larger G-type similar to our Sun and a smaller, cooler M-type, pirouette around each other every 27 days, constantly tweaking the gravitational landscape. Normally, such a dynamic environment would shred any orbiting planets within millennia, but Kepler 453b survives by keeping a respectful distance, completing one full orbit every 240 Earth days. Even then, its position is a razor's edge. Computer models show that moving just 10% closer to the stars would destabilize its path, sending it careening into space or spiraling to a fiery demise. Now picture the seasons here. On Earth, axial tilt gives us predictable winters and summers, but Kepler 453b faces a triple whammy of stellar chaos. First, the stars' changing distance from each other alters the total sunlight hitting the planet. Some years they huddle close together, flooding the world with heat, while other years they drift apart, creating a deep stellar winter. Second, the planet's own orbit introduces temperature swings as it moves closer or farther from the binary pair. And third, because the stars aren't equally bright, their combined light flickers like a cosmic strobe, some days dominated by golden G-type radiance, others bathed in dimmer M-type crimson. The result, a climate that lurches between extremes where a decade-long summer might suddenly collapse into a frigid super winter lasting just as long. Yet against all odds, this gravitational roller coaster might still harbor life. The planet's estimated surface temperature sits snugly in the liquid water range, and its 2.5 times Earth's radius suggests a thick atmosphere that could buffer wild temperature swings. What kind of life could thrive here? Perhaps organisms with ultra-flexible metabolisms, capable of hibernating through cold spells and surging into activity during brief golden ages of stability. Or maybe photosynthetic life that switches between harvesting different wavelengths as the dominant star changes, like plants that alternate between red and yellow leaves. The most tantalizing clue lies in Kepler 453b's transit timing variations, tiny wobbles in its orbit hinting at a possible moon. In this system, a large moon could be a game changer, stabilizing the planet's axial tilt to prevent climate free fall. Imagine a habitable moon where tides aren't ruled by one sun or two, but by their ever-shifting gravitational tug of war, creating shores where waves pulse in rhythms no earthly ocean could replicate. For astronomers, this planet is a masterclass in cosmic resilience. It shouldn't exist, yet it does, proof that habitable real estate comes in flavors we're only beginning to taste. Every orbit is a high-stakes gamble with gravity, a reminder that in the right conditions, even the fiercest stellar duets can cradle worlds where life might one day hum along in the chaos. Kelt 9b isn't just hot, it's a cosmic forge where the very laws of chemistry unravel under temperatures so extreme they make lava look lukewarm. Crowned the hottest planet ever discovered, this ultra-hot Jupiter simmers at a staggering 7,800 degrees Fahrenheit on its dayside, hotter than some stars. At that heat, metals like iron and titanium don't just melt, they vaporize, turning the atmosphere into a swirling metallic mist where molecules are ripped apart atom by atom. What makes this planet truly monstrous is its violent duality. Tidal locking ensures one side eternally faces its blue-white host star, a stellar furnace bombarding it with ultraviolet radiation 200 times more intense than Earth receives from the Sun. Here, even the toughest molecules, water, carbon dioxide, methane, are instantly shattered into their elemental components, creating an atmosphere of free-floating atoms and charged particles. But as these atomic fragments are blown toward the cooler night side by supersonic winds, something eerie happens. They reassemble into new compounds in midair, only to be torn apart again when the winds carry them back into the inferno. The result, a perpetual chemical recycling plant where the sky endlessly deconstructs and rebuilds itself in a macabre loop. The implications for atmospheric chemistry are mind-bending. On Earth, molecules like water or carbon dioxide are stable, enduring for millennia unless acted upon. But Celt-9b's atmosphere resembles the primordial soup of the early universe, a place where chemistry happens at the speed of a particle collider. Recent studies detected traces of iron and titanium vapor floating high in its atmosphere, the first time heavy metals have been spotted escaping a planet's gravity. Some researchers speculate the night side might even host clouds of metallic droplets, raining molten iron back onto the planet's broiling surface. Yet the most unsettling revelation is this planet's fate. Orbiting just 3 million miles from its star, Celt-9b is being evaporated alive, its atmosphere bleeding into space at a rate of 10 billion grams per second. Spectroscopic observations reveal a comet-like tail of hydrogen gas stretching hundreds of thousands of miles, proof that even gas giants can't withstand such stellar fury forever. In another few million years, this world might be reduced to a naked core, a scorched relic of what was once one of the most extreme planets in the galaxy. Celt-9b isn't just a scientific curiosity, it's a portal to understanding how planets behave under conditions we once thought impossible. It's a place where the periodic table is more like a suggestion than a rulebook, and where the sky itself is a battlefield between creation and destruction. If chemistry is the language of the cosmos, this planet speaks in screams. Among the galaxy's countless mysteries, TOI 1452b stands out as a world that may hold more water than all of Earth's oceans combined. This super-Earth, orbiting a dim red dwarf star 100 light-years away, isn't just wet, it's a potential aquatic behemoth, with preliminary data suggesting liquid water could account for up to 30% of its mass. Compare that to Earth, where water makes up less than 1% of our planet's total weight, and you begin to grasp the staggering scale of this aquatic wonder. Detecting an ocean buried beneath miles of ice or rock isn't easy, but astronomers have developed ingenious methods to peer beneath the surface. When TOI 1452b transits its star, subtle changes in the starlight's polarization can hint at the presence of a reflective global ocean. Other clues come from the planet's density. While it's nearly 5 times Earth's mass, its radius suggests a composition far lighter than rock alone. Models point to a world wrapped in a deep, high-pressure ocean, perhaps dozens of miles deep, capped by a thick layer of ice or a steamy, water-rich atmosphere. The kicker, tidal forces from its star, might keep this ocean liquid by flexing the planet's interior, generating enough heat to prevent a global freeze. What would it be like to stand on such a world? Forget beaches or coastlines, this planet's surface might be an endless abyss, with crushing pressures turning water into exotic forms like superfluid ice or electrically conductive phases we've never seen. If life exists here, it wouldn't resemble Earth's sunlit reefs, but might lurk near hydrothermal vents on the ocean floor, thriving in perpetual darkness. The sheer volume of water raises wild possibilities. Could there be layers of different ocean zones, each hosting unique ecosystems separated by pressure gradients or chemical boundaries? For astrobiologists, TOI 1452b is a tantalizing test case. Earth's life began in water, so a world with 100 times more of it might amplify the chances for biology. or create conditions so extreme they rewrite the rules for habitability. The discovery challenges our definitions of Earth-like planets, proving that water worlds come in varieties far stranger than we ever imagined. One thing's certain: if this planet's oceans are real, they're proof that the universe doesn't just dabble in water, it sometimes paints entire worlds with it. LTT 9779b doesn't just reflect light, it throws it back with the arrogance of a disco ball in deep space. This ultra-shiny world, orbiting a star 260 light-years away, boasts the highest reflectivity ever measured in an exoplanet, bouncing around 80% of its starlight like a cosmic mirror. To put that in perspective, Venus, the brightest planet in our sky, reflects about 65% of sunlight, while Earth's oceans and clouds manage just 30%. But LTT 9779b, it gleams with such intensity that if you could stand on its surface, though you'd be incinerated instantly, the ambient light would be blinding, as if the entire sky were a polished chrome dome reflecting a never-ending sunrise. The secret to this planet's brilliance lies in its atmosphere, a searing metallic soup of titanium and silicate vapors. At temperatures soaring over 2000 degrees Celsius, these metals don't just hover as gases, they condense into high-altitude clouds, forming a global shield of microscopic mirrors. Unlike Earth's water vapor clouds, which scatter light in all directions, these metallic particles act like precision reflectors, catapulting starlight back into space with eerie efficiency. The result is a planet so luminous it defies logic, turning the familiar concept of day and night into a surreal performance. On the day side, sunlight ricochets off this cloud layer with such force that the planet's glow is detectable from Earth, while the night side, though cooler, still shimmers with residual heat trapped beneath the reflective blanket. Detecting something this bright sounds easy, but it's a paradox of astronomy. Highly reflective planets are often harder to spot than dark ones. Most exoplanet searches rely on the transit method, watching for a star's light to dim as a planet crosses in front of it. But when a planet reflects most of its light, like LTT 9779b, the dip in brightness during transit is subtle, like trying to spot a slight flicker in a spotlight. To make matters trickier, the planet's own glare can drown out the faint shadow it casts. Astronomers only confirmed its existence by combining data from multiple telescopes, teasing out its signal like a whisper in a hurricane. What's truly bizarre is how this mirror world survives its own extravagance. Nestled dangerously close to its star, LTT 9779b completes an orbit in just 19 hours, a proximity that should have vaporized its atmosphere eons ago. Yet somehow, the very clouds that make it shine also act as a protective shield, reflecting enough stellar radiation to prevent total atmospheric annihilation. It's a delicate balancing act. Too much reflection and the planet's interior would freeze, too little and its skies would boil away. This equilibrium suggests the planet might be cloaked in a self-regulating feedback loop, where the metallic clouds thicken or thin in response to stellar intensity, a natural thermostat forged in the crucible of space. The implications stretch beyond one shiny oddity. If metallic clouds can stabilize planets in extreme environments, they might be more common than we thought, lurking in the atmospheres of other ultra-hot worlds. Some researchers even speculate about cold mirror planets, icy worlds with reflective methane or nitrogen clouds hiding in the outer reaches of their systems. And then there's the aesthetic wonder. A civilization orbiting LTT 9779b would witness skies unlike any other, where light doesn't just filter through the air but dances across it, fracturing into prismatic flares every time a metallic cloud drifts by. In the end, this planet isn't just a curiosity, it's a challenge to our assumptions. A world that mirrors its star so perfectly forces us to reckon with the diversity of planetary survival strategies. Out there, in the silent dark, beauty and brutality often wear the same gleaming face. Imagine a world where the horizon isn't crowned by one sun, or even two, but three, each painting the sky in shifting hues of gold, amber, and crimson. Welcome to HD 131399b, a planet where triple sunrises aren't just possible, they're a daily spectacle. Nestled 340 light-years away in the constellation Centaurus, this gas giant exists in a gravitational ballet so precise it defies the chaos typically expected of multi-star systems. For most of its 550 Earth-year orbit, the planet basks in perpetual daylight, its skies dominated by a trio of stars locked in an intricate celestial waltz. The mechanics of this three-star tango are nothing short of breathtaking. The primary star, HD 131399a, is a young, hot sun nearly twice as massive as our own, orbited by two smaller companion stars that pirouette around each other like dancers spinning in tandem. The planet itself circles the primary star at a distance roughly twice that of Pluto's orbit around our Sun, far enough to avoid being torn apart by competing gravitational pulls, yet close enough to feel the full spectacle of its stellar trio. For about half its marathon orbit, all three suns cluster close enough in the sky to create overlapping sunrises and sunsets, casting triple shadows that stretch and merge across the planet's cloud tops. At midday, the primary star dominates with a fierce white glow, while the secondary pair, one orange, one red, hang like radiant jewels in the heavens, their light blending into an otherworldly twilight even at high noon. Seasons here aren't just a matter of axial tilt, they're a symphony of changing light. When the planet swings to the outer edge of its orbit, the three stars drift apart in the sky, creating staggered dawns where one sun rises hours before the others. During this phase, night becomes a fleeting concept as the dimmest star lingers long enough to bathe the landscape in an eerie, ruby-tinted glow. But the true marvel comes when the planet passes between the primary star and the binary pair. For a few Earth decades, the two smaller stars orbit each other so close that they appear as a single, pulsing point of light, while the primary star looms large, a configuration that floods the skies with a kaleidoscope of colors from lavender to fiery copper, as differing wavelengths of starlight collide and scatter. What would it be like to stand beneath these heavens? Picture ammonia clouds swirling in bands of peach and indigo, illuminated by light arriving from three different angles. Shadows wouldn't just darken, they'd fracture, splitting into faint, overlapping silhouettes that shift with the star's movements. At certain times, the primary star's glare might eclipse the fainter duo, casting the world into a momentary hush before they re-emerge, their light refracting through the planet's upper atmosphere to create prismatic halos. The sheer improbability of HD 131399b's stability is what captivates astronomers. Most multi-star systems eject planets or destabilize their orbits within millions of years, yet this world has endured for an estimated 16 million, a testament to the delicate equilibrium of its dance. Some theories suggest its wide orbit acts as a buffer, minimizing gravitational tugs, while others propose its massive size, about 4 times Jupiter's mass, anchors it against disruption. Whatever the reason, its existence expands the boundaries of where we might hunt for habitable worlds, proving that even in stellar crowds, planets can find harmony. Yet the most haunting beauty lies in the ephemeral nature of its skies. Unlike Earth's predictable cycles, HD 131399b's celestial displays are never repeated exactly. Each triple sunrise is a once-in-an-epoch arrangement, a fleeting masterpiece written in light and gravity. It's a reminder that the universe's artistry isn't just vast, it's endlessly inventive, crafting wonders where we least expect them. K222b isn't just a planet. It's a cosmic hourglass, its sands draining away into the void as we watch. This doomed world, orbiting a dim orange dwarf star 800 light-years away, is evaporating at a rate so staggering, astronomers estimate it's losing 10 Olympic-sized swimming pools worth of mass every second. The culprit, a relentless barrage of radiation from its host star, peeling away the planet's surface layer by layer and sculpting it into a surreal, comet-like shape with a tail of debris stretching over 600,000 miles. What makes this disintegration so mesmerizing is how we're witnessing it in real time, or as close as astronomy gets. Unlike most planetary discoveries, which offer static snapshots of a world state, K2-22b's death throes unfold across observable years. NASA Kepler Space Telescope first caught hints of the chaos in 2015, detecting bizarre, asymmetrical dips in the star's brightness. Instead of the clean, U-shaped shadows cast by spherical planets during transit, K2-22b's light curve looked like a jagged scar with erratic fluctuations before and after the main eclipse. The explanation: a vast cloud of dust and vapor trailing the planet, its particles scattering starlight like a celestial veil caught in the solar wind. Zoom in closer and the physics becomes even wilder. The planet's surface, likely a mix of molten rock and vaporized metals, is being blasted into space so forcefully that its debris tail doesn't just drift, it accelerates. Radiation pressure from the star acts like a cosmic slingshot, propelling the dust particles outward at speeds exceeding 20,000 miles per hour. This creates a dynamic, ever-changing tail, its density shifting as new material erupts from the planet's surface while older dust disperses into the void. At this rate, models suggest K2-22b could shed its entire mantle within the next 100 million years, leaving behind a naked core of iron and nickel, a planetary skeleton slowly spiraling into its star. The detection method itself is a stroke of astronomical ingenuity. Normally, exoplanets are found by measuring regular, periodic dimming as they transit their stars. But K2-22b's dusty envelope betrays its presence through secondary clues: subtle changes in the star's light spectrum as the tail's particles absorb and re-emit specific wavelengths. By analyzing these fingerprints, researchers can even estimate the tail's composition, likely a mix of vaporized silicates and metals like magnesium and iron, the scorched remains of what was once a rocky super-Earth. What's truly humbling is the scale of this erosion. Earth loses atmosphere to about 90 tons of hydrogen daily, but at that rate, our air would last billions of years. K2-22b, by contrast, is hemorrhaging mass so fast that if Earth were in its position, our oceans and continents would be stripped to the core in under 1 million years. This isn't just planetary aging, it's a violent, accelerated unraveling, a reminder that even worlds have lifespans and some meet spectacular ends. As we watch K2-22b dwindle, it offers a morbid preview of our own solar system's future. Billions of years from now, as the Sun swells into a red giant, Mercury and Venus may face similar fates, their surfaces boiled away into shimmering stellar winds. For now, though, this distant, disintegrating world is a laboratory for understanding how planets die, not with a bang, but with a whisper of dust fading silently into the cosmic dark. Out of the ashes of a star's violent death rises something that shouldn't exist: PSRB 1257+12, a millisecond pulsar playing host to not one, but 3 planets that defied annihilation. This cosmic graveyard, located 2,300 light-years away in the constellation Virgo, spins at a dizzying 161 times per second, blasting the surrounding space with lethal gamma rays and radio pulses powerful enough to sterilize any known life form. Yet somehow, against all odds, planetary bodies cling to existence in this radioactive inferno, the ultimate survivors in a celestial horror story where the rules of formation were rewritten by destruction. These worlds weren't just born into hardship, they emerged from Armageddon itself. The pulsar they orbit is the collapsed core of a once massive star that went supernova, an explosion so violent it should have vaporized any nearby planets. The shockwave alone would have unleashed more energy in seconds than our Sun will produce in its entire lifetime, enough to rip apart gas giants like tissue paper. Yet here they are, three rocky bodies dubbed Draugr, Poltergeist, and Phobter by astronomers, each named after mythological spirits of the dead, as if to underscore their otherworldly resilience. The smallest is barely twice the mass of our moon, while the largest measures about 4 times Earth's heft, all crammed into orbits smaller than Mercury's. How do planets form in such a hostile environment? That's the million-dollar question shaking astrophysics to its core. Traditional models suggest planets coalesce from dusty disks around young stars, not the corpses of stellar explosions. One radical theory proposes these worlds are the zombified remains of a gas giant, its outer layers obliterated by the supernova while its iron-rich core somehow survived. Another suggests they're second-generation planets, born from the debris of shattered stars and white dwarfs that collided in the pulsar's chaotic aftermath. Then there's the wildest possibility, that these are the lone survivors of an original planetary system, their siblings long since vaporized, their orbits shrunk over eons by the pulsar's relentless radiation. The real magic lies in how we found them, not by watching for starlight dips or gravitational wobbles, but by decoding the pulsar's radio pulses like cosmic Morse code. As the planets tug on the pulsar with their gravity, they cause infinitesimal timing variations in its spinning beacon. Imagine a lighthouse whose flashes arrive a millisecond early or late because unseen worlds are pulling its position ever so slightly. It took astronomer Alexander Wolskson months of painstaking observation in the early 1990s to tease out these nanosecond irregularities, proving that planets could exist in places no one thought to look. The precision required borders on absurd, detecting orbital shifts equivalent to a single hair's width across the distance from Earth to the Moon. What does their existence teach us? For starters, that planetary systems are far more adaptable than we imagined. If worlds can emerge from supernova wreckage, they might lurk around neutron stars and black holes, places once written off as planetary deserts. It hints at exotic materials too. These planets could be forged from titanium or crystallized carbon, their surfaces potentially studded with mountain-sized diamonds formed under pressures we can't replicate on Earth. There's even speculation about their skies, not sunsets but auroras induced by the pulsar's magnetic fury, painting the heavens in radioactive rainbows visible through impenetrable clouds of charged particles. Perhaps most mind-blowing is the timescale. Pulsars are cosmic timekeepers, their spins slowing by mere seconds over millions of years. The planets orbiting PSRB 1257 plus 12 might outlast entire galaxies, their orbits decaying so gradually that they'll still be circling this dead star when the universe itself grows cold. They're monuments to persistence, proof that where there's chaos, there's also the potential for rebirth, and that nature's creativity flourishes even in the graveyards of stars. We've journeyed through diamond rain and molten glass storms, but now we arrive at the most enigmatic possibility of all, a planet not made of atoms, not bound by light, but sculpted from the universe's greatest mystery, dark matter. This isn't just science fiction. It's a fringe theory gaining traction among astrophysicists desperate to explain bizarre gravitational quirks across the cosmos. Imagine a world with no surface to stand on, no atmosphere to breathe, no light to reflect, just an invisible mass bending space-time like a cosmic ghost, detectable only by the way it tugs on the stars around it. The idea of dark matter planets arises from gaps in our understanding of gravity. Across the galaxy, astronomers observe stars wobbling as if tugged by unseen companions, yet when they point telescopes at these anomalies, they find nothing. No gas giants, no brown dwarfs, not even black holes where they should be. Some researchers suggest these gravitational mirages could be rogue planets made entirely of dark matter, particles that don't interact with light or ordinary matter except through gravity. Unlike the planets we know, these phantom worlds wouldn't form from swirling disks of dust and gas. Instead, they might condense directly from clumps of dark matter in the early universe, collapsing under their own gravity into dense, invisible spheres drifting unseen between the stars. Behaviorally, these worlds would defy every convention. A dark matter planet wouldn't have a molten core or tectonic plates. Its structure would be a cloud of exotic particles bound together by gravity, their interactions governed by forces we've yet to fully understand. Heat wouldn't radiate from its surface because there is no surface, just a gradient of increasing density toward the center. If you could somehow touch it, which you couldn't, since dark matter passes through ordinary matter like a breeze through a screen door, the experience might feel like plunging your hand into a vortex of silent, icy wind, a sensationless pull toward an unfathomable heart. Detecting such a planet is the ultimate cosmic hide and seek. Traditional methods like transit photometry or radial velocity are useless when the target doesn't block or reflect light. Instead, scientists hunt for secondary clues, microlensing events where the planet's gravity briefly magnifies the light of a background star, or subtle distortions in the orbits of nearby visible objects. One tantalizing candidate lurks in the outer solar system, Planet 9, a hypothetical body whose gravitational influence might explain the odd clustering of trans-Neptunian objects. While most theories assume it's a rocky or icy super-Earth, a dark matter interpretation isn't off the table. If proven, it would mean we've been sharing our cosmic neighborhood with an invisible giant all along. The implications stretch beyond curiosity. If dark matter planets exist, they could solve the missing satellite problem, where simulations predict more dwarf galaxies orbiting the Milky Way than we observe. Perhaps some of these missing structures are actually dark matter planets masquerading as empty space. Or consider the wild possibility of dark matter ecosystems. If certain theoretical particles like actions interact weakly with each other, could they form complex structures within these worlds? It's a stretch, but the universe has surprised us before. For now, the hunt remains speculative, but tools are advancing. The upcoming Vera Rubin Observatory's ultra-deep sky surveys could catch a microlensing event betraying a dark matter planet's presence. Particle detectors buried underground might one day sense the rare interaction between a dark matter particle and ordinary matter, offering indirect proof. Until then, these phantom worlds linger at the edge of science, challenging us to rethink not just what planets are, but what they could be. The cosmos is vaster and stranger than we've dared to imagine, and somewhere in the dark, an entire class of worlds might be hiding in plain sight, or rather in plain shadow. From diamond rains to molten glass hurricanes, from rogue worlds adrift in the void to planets older than our galaxy itself, we've traveled through a cosmic menagerie that defies imagination. Every one of these 25 strange worlds shatters our assumptions, proving the universe is far wilder, far more inventive than we ever dared to dream. Think back to 55 Cancri, where mountains of glittering diamond rise beneath skies that rain gemstones, or HD 189733b, where 1,000-mile-per-hour winds hurl molten glass like celestial shrapnel. Remember the haunting darkness of TRES-2b, a planet blacker than charcoal, and the cosmic ballet of Kepler 16b, where double sunsets paint the sky in ever-shifting hues. Each of these discoveries isn't just a curiosity, it's a revolution, rewriting the rules of what a planet can be. What unites them all is their defiance. They refuse to fit neatly into our textbooks, challenging everything from how planets form to where life might take root. Take Gliese 436b, where water exists as scorching hot ice, or PSRB 1620-26b, a world 12 billion years old that survived the violent death of its parent star. These aren't just outliers, they're messengers from the edge of possibility, showing us that nature's creativity has no limits. Even the most hostile environments, like Kelt 9b, where metals vaporize in 7,000-degree heat, teach us that chemistry and physics can dance in ways we've yet to fathom. Yet for all we've uncovered, the most thrilling thought is this: we've only scratched the surface. Every strange planet we've found begs a dozen new questions. Could there be worlds made of dark matter, invisible giants hiding in plain sight? Might some rogue planet, frozen and alone, harbor oceans of liquid water beneath its icy shell? And what about those we can't even conceive of yet? Planets with structures or atmospheres so alien they'd make our current discoveries seem mundane. The universe has spent 13 billion years experimenting. We've barely begun to glimpse its laboratory. So tell us, which of these worlds left you awestruck? Was it the eternal diamond storm of 55 Cancri E, or the haunting glow of GJ504b, the pink planet frozen in its youth? Drop your favorites in the comments, and while you're at it, take a moment tonight to look up. Because somewhere out there, in the infinite dark, another impossible world is waiting, and it's only a matter of time before we find